Hello and welcome to all students in this our YouTube channel. Now students, we are in the topic of structure of atom. That is from the new syllabus of 11th chemistry, we are going to learn this chapter in detail. Students, we have already studied this chapter in your previous standard. In continuation with that previous knowledge, we are going to learn the new concepts which are uh, based on this chapter, that is structure of atom. So let us start. Now students, you will see this picture. In this simulation you will notice that the structure of atom, how it would be, and the rotating, the blue dots, they indicates electrons, and the protons and neutrons which are present in the nucleus that you have studied in your previous standard. So this is a model of an, what we can say, the atom. Now students, in continuation with that knowledge, we will learn what is meant by the charged particles in matter, and we will see how the discovery of subatomic particles will take place after that. First of all, we will learn the charged particles in matter. Now students, atoms have three types of subatomic particles that you already know, that is electrons, protons and neutrons. Electrons are nothing but the negatively charged particles, in bracket I have shown with its charge, that is e raised to minus, which indicates the electrons which are negatively charged. Protons are positively charged, and the neutrons have no charge, means they are chargeless. Therefore, these are the charged particles in which, in atom, protons and electrons, these are the only charged particles. Now students, in continuation with our previous knowledge, the mass of an electron is 1 upon 2000 the mass of hydrogen atom. In your textbook, this value they have mentioned. The mass of proton is equal to the mass of hydrogen atom and is taken as 1 unit. The mass of neutron is equal to the mass of hydrogen atom and is taken as 1 unit, that we have already studied in the some basic concepts of chemistry. Now students, let us see how the discovery of subatomic particles takes place. In 1900 century, J.J. Thomson discovered the presence of the negatively charged particles, which we are calling it as a electrons, in the atom. And in 1886, E. Goldstein discovered new radiations in gas discharge, and we are calling them as canal rays. These rays were positively charged. This latter led to the discovery of positively charged particles, and to that particles we are calling it as a protons in the atom. Now students, in 1932, Chadwick discovered the presence of particles having no charge in the atom, which we are calling it as a neutrons. So this is a brief history, and in detail we will go in our next slide. Structure of an atom. In this topic, first of all we will learn the history of its atom, that is Thomson's model of an atom. Students, according to the Thomson, an atom is similar to the Christmas pudding. The pudding had positively charged, and the electrons having negative charge were like plums on the pudding. Let us see this figure. You will notice that how the negatively electrons which are present in the positive pudding, and they are shown with the blue dots. And according to his imagination, he proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. And the second he has in the second point, he has proposed that the negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. Students, in the second figure, Thomson proposed this model, and he has represented uh, the Thomson atomic model in the figure. You will notice here. So, according to his figure, we can say that the negative and positive charges are equal in magnitude. So let us, if you count the positive and negatively charged particles, you will notice the same. Now let us go for the next point, that is Rutherford model of an atom, Rutherford's alpha scattering experiment. Rutherford allowed a beam of fast moving alpha particles having positive charge to fall on a thin gold foil. Students, these experiments also you have studied in your previous standard, but here we have mentioned some extra points here. He observed that the different observations he has made. The first thing is that most of the alpha particles passed straight through the gold foil. You will notice these blue rays. Out of all rays, some of them are passed as it is in a straight manner. Some of the alpha particles were slightly deflected by small angles, and that angles you will notice here in the figure. Very few of alpha particles appeared to rebound, means they get reflected back with making some angles. So according to his these observations, he has concluded that most alpha particles are undeflected, means which are passed as it is without making any angle, but few alpha particles are slightly deflected by making some angle. And the third observation, according to his experiment, he made that a few alpha particles bounce off nucleus, means they return back with making large angles. So conclusions from Rutherford's alpha scattering experiment, we can say that the most of the space inside an atom is empty. Why it is empty? Because most of the alpha particles passed straight through the gold foil. This is the reason behind it. So why we can say that most of the space inside an atom is empty. And according to the second observation, the atom had a small nucleus having positive charge. This is because why some of the alpha particles having positive charge were slightly deflected by making small angles. Means atom had a small nucleus having which has a positive charge, means there is a presence of protons. And according to the third observation, the size of the nucleus is very small compared to the size of the atom. This is because very few of alpha particles appeared to rebound, and most of the positive charge and mass of atom is in the nucleus. So that's why they get bounce back. So these are the conclusions from the Rutherford alpha scattering experiments. Now after that, Rutherford made a model of an atom in which he has stated some different statements. An atom has a positively charged nucleus at its center, and the most of the mass of atom is in the nucleus. The electrons revolve around the nucleus in different orbits. The size of nucleus is very small as compared to the size of the atom. So these are the Rutherford which he has mentioned in his model of an atom. So these are the very important points. Now students, let us study defects of Rutherford's model of an atom, means which are the outcomes from his model. Any particle in a circular orbit would undergo acceleration, and during acceleration the charged particles would radiate energy, means it radiates some amount of energy. So the revolving electrons would lose energy and fall into the nucleus, and the atom would be unstable. we know that the atoms are stable. So this is the picture. From this figure you will get here Rutherford has made a model of an atom in which he has stated that a very small positive charge nucleus is present at the center, while the green color dots they shows the negatively charged electrons in orbit around the nucleus. And the second thing is that he made an assumption like this: negatively charged electrons, if they revolve around the nucleus, then after some time they should fall into the nucleus, that is which is made up of positively charged nucleus. Now after that, students, Bohr's model of an atom, he has proposed that an atom has a positively charged nucleus at its center and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in a special orbits called discrete orbits, and in the figure you will notice that the different shells, these orbits are called shells and the energy levels are represented by the letters K, L, M, N. And to this K, L, M, N shells, the respective number is also provided here, 1, 2, 3, 4, etc. While revolving in the discrete orbits, the electrons do not radiate energy. So this is the Bohr which he has mentioned in his model of an atom. Now distribution of electrons in different shells. The distribution of electrons in the different shells was suggested by Bohr and Bury. The following are the rules for filling electrons in the different shells. And if you look at the maximum number of electrons in a shell is given by the formula 2n square, where n is the number of shell, that is 1, 2, 3, 4, etc. Suppose, students, the first shell, for K shell, we can calculate the number of electrons, means the electrons capacity in the first shell. According to the formula, if you substitute for K shell as number 1, you will get the capacity of electrons which are present in the first shell, that is 2n square. It means 2 into 1 square, you will get the answer 2 electrons. Now students, like that, corresponding L, M, N we have calculated, and the electron capacity we have got is 2, 8, 18, 32. Now students, this is the distribution of electrons in the different shells. And the second thing, the maximum number of electrons that can be filled in the outermost shell is 8. And after that, electrons cannot be filled in a shell unless the inner shells are filled. So students, this is the composition of atoms of the first 18 elements. This also provided in your textbook. If you look at the name of the elements, symbol, atomic number, number of protons, neutrons, electrons, and their distribution in KL, MN shell, valency, all the data you have provided it. And in our next lecture, we will learn the number, how to calculate the number of protons, neutrons, and electrons, as well as atomic number and atomic mass in our next lecture. Thank you very much.